Hi, I'm Adolph Oliver, and in this lesson we're going to talk about best value word problems. Where these come from is you often have two companies that offer the same product or service, and the question, of course, is which is the one that's the best value for you? In other words, for what you need, which one's going to cost the less? Well, of course, that often depends on how much of their particular product or service that you happen to need. What I'm going to do is treat this in a method that's normally used in intermediate algebra, known as break-even analysis. In fact, where that comes from is even more from business applications, because it's often used in business to determine what's the best company to go with if you need a particular product or service. So, here's what we're going to do. We're going to make an equation by equating the cost of buying the same X units, whatever it is that the company is providing, from each of the two companies and equate them. And that'll give us the amount where the cost is going to be exactly the same, what is known as the break-even. That's where this analysis gets its name, break-even analysis. And then after that, we'll show you how it's easy to be able to tell which one is the best way for you to go depending on how much of that product or service you're going to be buying. This, by the way, is a common thing you can use quite a bit in everyday life in comparing two car rental firms, for instance, or if you're getting a particular type of service, which one's the best way to go. Well, let's take a look at a beginning example here and show you how to set this up. Let's say that New Phone has a $7 monthly fee and charges 5 cents per telephone minute. Connect has a $22 fee and charges 2 cents per minute. What is the best deal if you talk 400 minutes in a month? Well, here's how you set it up. We've got the two companies. One of them's New Phone, and the other one happens to be Connect. Now, what we're going to do is jot down underneath each of these what their costs are, and then we'll build up from that. Okay, New Phone has a $7 monthly fee, so $7 fee, and it charges 5 cents per minute, 5 cents per minute of your phone calls. Okay, Connect, on the other hand, has a $22 fee, okay, for the month, but it only charges 2 cents per minute. Okay, well, what we're going to do is find the break-even. We want to find out how many minutes it'll be where the cost would be exactly the same for either one of these. So let's say M equals the number of minutes, and this will be, of course, minutes for the break-even that we're going to analyze. Okay. What would New Phone charge? Well, it's going to charge us $7 up front, whether we talk or not. That's the monthly fee. And then 5 cents. Now, you have to make sure that you put all the money in the same notation. So since we started with dollars here, I'm going to convert this 5 cents to dollars notation. So here it is, 0.05. That's 5 cents in dollars notation, times M, the number of minutes. Okay, well, we're going to equate that to what Connect would charge for the same M minutes. They charge $22 up front, but then it's only 2 cents, or 0.02 times M. Okay, solving this equation, it's a simple little linear equation, will then end up giving us what it is that is the number of minutes that are break even. Then we'll show you what's the best way to go depending on what you're talking. Okay, well, here we go. How do we solve something like this? We only want variables on the left, so this officially plus 7 will have to move. We only want plain numbers on the right, so the 22 is okay, so the plus 0.02m will have to move. Okay, so the plus 7 comes over as negative 7, and the plus 0.02 comes over as negative 0.02m. Okay, well, we've moved to plus 7, we've moved to plus 0.02. What do I end up with over here? 0.03m equals And 12 minus 7 gives me 15. Okay, well, to find m, the number of minutes where the cost will be exactly the same in both of these, we simply divide both sides by 0.03. Here we go. We get m then equals, well, let's see, what do we got here? 3 goes into 15 5 times, but then of course we got 2 decimal places down here. If you get your calculator out and turn around and divide this, you'll end up with m equals 500 minutes. Okay, 500 minutes then is the break even. If you were going to talk exactly 500 minutes, the cost would be exactly the same for both of the original companies up here. Okay, New Phone and Connect. Well, what's the best deal if you plan to talk only 400 minutes as given in the problem? Well, here's the idea. If you're going to talk less than what the break-even amount is here, okay, if you're going to do less, then go with the guy who is less up front. Okay, so break-even is 500 minutes. We're only going to be talking 400 minutes. So the total cost would be less if we went with New Phone. Now, if you're going to talk more than 500 minutes, then you turn around and go with the other guy. Okay, and he'll end up charging you less because of the lower per minute fee, but it is even until you get to 500 minutes. Okay, so in this particular problem, you'd give the original equation here for the break-even. The break-even is 500 minutes, and since we're only talking 400 minutes, that means we'd want to go with the guy who is less on the fixed upfront cost, and that's New Phone. Okay, let's look at a car rental type of thing. Here's another example, same type of comparison. Best rents a car for $18 per day and 30 cents per mile. Value rents the same car for $24 per day and 25 cents per mile. Which costs less if you plan to drive 150 miles? Well, once again, set up the two companies. Here's Best, and the other one is Value. And let's jot down what it is they're going to charge us. Best has $18 per day. Okay, and let's see, what did it say here? Oh, 30 cents per mile. 30 cents per mile. Okay, on the other hand, Value over here is going to charge us $24 per day, and the mileage cost is 25 cents per mile. Okay, well, we're talking about miles here. Let's see, a good variable to use for miles. Let's use our old m again here, but this time it's for miles. So m will be the number of miles. And what we do then is calculate the charge for each one of these and set them equal, and that'll give us the number of miles that is the break-even value, where the cost would be the same with either one of these guys. Okay, well, it's not difficult to set these equations up again. Here's the fixed fee per day for Best, $18, and then they're going to add 30 cents per mile. Well, remember, we've got to have it in the same notation, so since the 18 is in dollars, I'm going to change the 30 cents to 0.3. You could make it 0.30 if you want. I'll go ahead and do that. And times M. Now, what's the cost over here for Value? Well, it's going to be $24 for the whole day, plus 0.25 times the number of miles. Well, we set these equal to each other. This is what gives us the break-even. Now, as usual, let's solve this. Remember, we got to move numbers to the right, so the plus 18 will come over here as negative 18. And we got to move the variable to the left, so the plus 0.25 will come over as negative 0.25m. Okay, let's see, plus 18, I moved to negative 18, plus 0.25 to negative 0.25. I'm correct in that. Now, let's see what we have left on each side. On the left side, I end up with positive 0.05m equals over here 24 minus 8. That's going to give me 6. Okay, well now, divide both sides by 0.05, and here's one of the things you can do. I can turn around and take this 6 over here and add 2 decimal places after it, and that makes it 6.00, and that might make it a little bit easier to reduce this. Okay, the 0.05s cancel out on the left, so what are we going to get for the break even here? Well, M is going to equal 5 goes into 600. If we move the decimal point over 2 places in both of these, it goes in 120 times. If you took 6.00 and divided it by 0.05 in your calculator, you'd get 120. So, what is the break even here? 120 miles. Okay, how far were we planning to drive? We were planning to drive 150. Now remember, here's how you work this break-even value. If you're going to do less than break-even, then find the guy who has less money up front. Okay, in other words, what they charge for the whole time. If you're going less than 120, you'd go with Best over here because he has $18 up front versus 24. But if you're going to do more than this, okay, then go with the other guy. The other guy has less per unit that you're using, less per mile, and that'll give you a better price if you're going to be traveling more than the break-even. And of course, remember, we said you were going to be planning to drive 150 miles. So, once again, let's emphasize this. Once you find the break-even value, and you do that by setting up the 2 equations and putting them equal each other and solving it, if you're going to travel less than the break-even, go with the guy that's less up front. If you're going to be traveling more, simply go with the other guy. Okay, let's look at another example here. Once you get the hang of these, they're simple to work, and there are lots of everyday things where you have comparisons like this. Let's take a look at this one. Fast Air charges $80 for a flight plus $2 per bag. On Time charges $56 for the same flight plus $8 per bag that you're taking with you. Which costs less if you have 3 bags? Okay, well again, the best thing to do is to turn around and just list the costs for both of these. So we got Fast Air and we have On Time. Now, let's go back and get this information out. Fast Air is going to charge us $80 for the flight, okay, plus $2 per bag. $2 per bag. Okay. On Time charges $56 for the same flight, plus $8 per bag. Okay, well, let's equate these up. Now, the thing that varies here is the number of bags that you're going to have. So let's use B for the number of bags. You could use X if you wanted, but nice to use a letter that reminds you what you're working with. Set up the costs in both of these. Fast Air, the flight is $80 plus $2. Now notice this is the same money, both in dollars, so we just use the 2 times B. On Time over here charges $56, but plus $8 per bag. Okay, equate these equal to each other and solve them, and that's going to give us the break-even value like we've done before. Again, the plain number on the left side has to move over, so we'll end up over here with negative 80. And on the right side, we've got to move the variable. The plus 8b comes over as negative 8b. So now we've moved the plus 80 and the plus 8b. On the left side here, I now have negative 6b equals, and over here, 56 minus 80, I think that's going to give me negative 24. Okay, well, of course, divide both sides by negative 6, okay, and that will give me what the break-even is for the number of bags. Looks like B equals, this just reduces to positive 4, So the break even is 4 bags. Okay, well, if we were going to be taking 4 bags on the flight, the cost would be exactly the same in both of these. If you put b equals 4 in for both the b values, we wouldn't care which one of these guys we took. But over in the problem we have here, it says which costs less if you have 3 bags. Okay, well, the break even is 4, so 3 bags is going to be less. That means we go with the guy that's less up front. Actually, the guy that's less up front is going to be going this way. It's closer, so let's write it like this. Okay, this is the guy who is less. Now, let's look at this again. Here's the idea. What we did was we equated the costs of both of these. 80 plus 2b equals 56 plus 8b. We solved it and found out that the break even was 4 bags. If you were taking 4 bags on the flight, the cost would be exactly the same in both. Okay, well, we're only taking 3 bags. That's what was given to us in the problem up here. So that being the case, that's less than the break even. So you look up here and see which of the guys is less up front. Well, the less up front is on time at 56. So since we're using less than the break even, we go with the guy that's less up front. And so we'd say we'd want to go with the on time. That would save us some money. Okay, well, like I said, there are lots of different types of problems like this. Here's another example here. We're talking about roadside service now. And sometimes you have a little twist in terms of the time units on this. So let's watch this one carefully. We have another outfit called On Time, which charges $34 plus $16 per 15-minute time period for emergency roadside repairs. You know, if your car breaks down the road and you have to call somebody up to come and get it running for you again. Pronto charges $50 just to show up, but then only $12 per 15-minute period. Which costs less if you need 45 minutes worth of repair service? Well, first off, let's go ahead and summarize both of these guys. We've got On Time and Pronto. Okay, now, On Time charges $34 just to show up and say hello to you. Plus, then they're going to charge $16 per 15 minutes. Okay, now, Pronto is going to charge you $50 to show up, but then plus only $12 per 15-minute time period. Okay, well, here we go. Let's again equate these two. Let's make x here equal the number of 15-minute time periods. Okay, remember they're charging you every 15 minutes. So now let's put the cost together. On Time here is going to charge $34 just to show up, and then plus $16 each of those 15-minute time periods. So 16 times x, these are both in dollars notation, so I've left them as whole numbers here. Pronto is going to charge you $50 to show up, but then $12 for each one of those 15-minute time periods, or 50 plus 12x. Now again, for break even, we want to find out where the cost is even or the same in both, so we equate these two. Now, as before, we have to move the plain number that's on the left, so the plus 34 comes over as negative 34. The plain variable, or the variable that's on the right, plus 12x, has to move over to the left. It's negative 12x. So we've moved both of these guys. What do we end up with? Well, on the left side over here, we've got 4x equals 50 minus 34 is 16. So divide both sides by 4 here. We get x equals 4 of these 15-minute time periods. This is the break even right here. Okay, well, let's see what we're going to need in service. We were going to need a total of 45 minutes, which is 3 of those 15-minute time periods. 3 times 15 is a total of 45 minutes. Okay, so we go back down and take a look at our break even here. It's 4 of these 15-minute time periods. Well, we're only going to need 3 of them. That's less than the break even. So again, if you're going to use less than the break even amount, go with the guy that's less up front. Who's less up front? Well, pronto is 50, on time is 34. The 34 is less up front. So since we need less of the break-even amount here, that means we go with the guy that's less up front. So on time would be the better cost for us if we need just 3 of these 15-minute time periods. Okay, so when you do these, watch out for things like this. Okay, you're not always going to have per minute or per hour. You can have things like this. How many 15-minute time periods? Okay, one last look here at a similar type of comparison thing. We're driving across a bridge, and here we go. A monthly bridge toll book costs $60 and allows unlimited trips over the bridge. Without the book, each trip costs $5. Should you buy the book if you will make 15 trips next month? Okay, well, here we go. We'll put down with the book. Okay, and then without the book. Many times you have situations like this. Do you get the special discount deal, or do you just pay the regular price? This is what this boils down to. Okay, with the book, a monthly toll book costs $60, so there is the $60, but then it's plus $0 per trip. In other words, what happens here is that you end up having not to pay for any of the trips across the bridge. You only pay the $60 up front, and all your bridge trips then are free for that month. Now, without the book, okay, so without the book is 0 up front. We're not buying the book, but then plus $5 per trip. Okay, so here's our differences. With the book, you're paying $60 up front, but then nothing per trip. Without the book, you don't buy the book, so it's 0 up front, but then it's $5 per trip. Okay, well, let's put the cost together here. The idea is similar to what we've done before. With the book, we're paying $60 up front. Let's forget in here, let's say t equals the number of trips. Okay, we do need that variable, so there it is. Now, how much per trip here? Well, I'll put it down here, plus 0 times t. Okay, many times folks would leave this off, but just to make it look like we've done before, here it is, $60 plus 0 times each of the trips. Now, on the other hand, over here, 0 up front, but plus 5 times the number of trips. Okay, well, equate these two guys equal to each other. We simply get 60 on the left and 5t on the right. To solve this, the easiest thing to do is just interchange the sides. 5t equals 60. Divide both sides by 5, and I get t equals 12, and of course this is trips, so there we go. This is the break even. So if you were going to be making 12 trips in a month, it would cost exactly the same if you bought the book and then didn't pay anything per trip, versus don't buy the book and pay $5 each time you go across. Okay, well now, in our particular problem, okay, we were planning to make 15 trips next month. Now remember, if you're going to do less than the break even, then you go with the guy that's less up front. But our 15 trips is more than this, so we're going with more here. So what we do is pick the guy that's more up front, but not charging anything per trip. We'll be better off just turning around and doing it this way, because our 15 trips is more than the break-even. Now let's remind you again how this works. Once you find the break-even, and it's easy, set up the costs of each, set them equal, solve for what is the break-even amount. If what you're going to be doing is less than the break-even, go with the guy that's less up front, which of course would be the $0. If you're going to be doing more than this, then go with the guy who's more up front, because what will happen is this lower per trip cost will then save you money. So going 15, we'd want to get the book. We'd be saving money